Good morning. Welcome to Unit 3 of the course Advanced Power System Protection. In Unit number 3, we will discuss about the busbar protection. We will start with the introduction to busbars, and then we will move on to the differential protection which is employed for protection of busbars. And then we will discuss different types of differential protection that are employed for busbars in this unit. So in today's class, I will give you a glimpse of about the busbars, why they are used, and why protection should be provided for the busbars. In the last lectures, we have seen unit number 2 and unit number 1, where we have come across the digital relays and the different algorithms which are required to process the data in digital relays. In this video lecture, I will give an introduction to relays and why we should go with providing protection for busbars. I hope that by the end of this lecture, you will be able to describe the need for busbar protection. So coming to the topics, I will start with the busbars, what actually busbars are, and the need for busbars, and then we move on to advantage and disadvantage of having busbar system or conventional wiring systems. And next we will move on to why we should provide protection for busbars. Now coming to the introduction part, why we do require busbars. An electric busbar is basically just like a bus ducts, or just like your electrical busway, which is a system of insulated conductors. And these are exclusively used in distribution systems, particularly for distributing the electric power within a building or a facility. So, in olden days, we used to have these traditional wiring systems. But nowadays, we are employing these busbar systems because they offer many advantages for us. We can have an improved efficiency, greater flexibility, and also improved safety also. So, how actually these busbars provide us a higher efficiency and a greater flexibility, that we will see in today's class. So, before I go on with this topic of busbars, let me clear you one thing. Busbar is just like a material, a thick conductor, which is basically made up of either copper or aluminium or brass. Most of the times we do employ copper, but since copper cost is high, we normally go with aluminium busbars. So they are just like a flat or bar-like shape. So normally what happens is nothing but in olden days we used to have a combination of wires, right? Let us suppose if I want to join the wires, so I'll be taking two wires and I'll be joining them. So rather than joining the wires, normally you see the wires will be capable of carrying 1 ampere current, 5 amperes of current, 10 amperes of current. For 20 amperes or 50 amperes of current, the wire thickness will be high. So it is difficult for us to join 2 or 3 wires, each of capability of carrying of 50 amperes. It is difficult for us to join them and applying the plaster to them, right? So to avoid that thing, what the engineers have developed is busbar mechanism. So busbar mechanism is just like a bar of copper or aluminium, where you can join the wires at different positions. So since the bar is made up of copper, so I will join one wire at this point, one wire at this point, one wire at this point. So there is a zero resistance between them because the wire is basically made up of copper or aluminium. So since see the bus bar now let us suppose if I am joining it 350 amperes. So 350 ampere wires. So which means that the bus bar must be capable of carrying 150 amperes of current. So in other words, let us suppose if we take, if I do have an apartment, let us suppose an apartment building is there. Now 50 houses are there in the building. Now I will be getting one incoming connection from the nearby transformer. And from that connection, I am supposed to provide supply to 50 households in my apartment society. So how can we do? Should I get a wire and 50 wires from all these homes and should I tie up? No, because each home will be carrying a wire of current carrying capability of 50 amperes or 60 amperes, let us suppose. Normally it will be 15 to 20 amperes, but let us suppose if they are capable of 50 amperes or so. So should I connect this incoming wire with this 50 wires, each of 50 amperes? It is difficult for me, right, to use a plaster and just like combination of wires. So what I'll be doing? I'll be joining it to a bar, copper bar. So I'll be connecting this 50 at this 50 points, 50.1 to 0.50 and 51. I'll be connecting this incoming. So it is just like a physical joint of wires. Now a professional joining of wires, what we call it is, right? Which obeys KCL. The incoming current is equal to the sum of outgoing currents. The sum of incoming currents is equal to sum of outgoing currents. And the bar will be very thick because it is supposed to carry hundreds of currents most of the times. So normally it will be bar type of structure, flat bar type of structures, but depending upon the requirements, shaped structures are also coming into picture. Now, moving ahead. So, what is the advantage of this one? See, when compared to the traditional wiring, these are very easier to install and maintain. Because if I want to remove this one particular wire, so if, let us suppose if I have a joint of 4 or 5 wires, if I want to remove one wire, what I should do, I should remove the plaster and again I should remove one wire, right? So it is a typical task if I do have multiple number of wires and higher capacity. Now this is just like a bar where I am connecting it with pins. So if I want to remove it, I can just remove one particular wire. So installation and maintenance point of view, it is very easier with a busbar system. So that's what I have written here. So it is easier to install and maintain than traditional wiring, which will reduce the overall installation and maintenance cost. And also, I can house these switchgear, panel boards, etc. in separate houses, right? So separate arrangement can be provided for the switchgear and panel boards, etc. So that's what I have mentioned here. Typically housed inside switchgear, panel boards, and busway enclosures for local high current power distribution. I'll show you at the end of this lecture how these housings are done. So normally these bus bars are uninsulated, but nowadays insulated bus bar is also coming. Just for a presentation point of view, to have some RYB differentiation or with neutral differentiation, they are just providing it with insulation. But normally they are uninsulated and they do have sufficient stiffness because they can be, sometimes you can have them to 1 meter length also. So normally they do have sufficient strength and stiffness such that they can be supported in air with the help of insulated pillars. So this particular property, it helps them to allow sufficient cooling of the conductors because they will be long enough and they will be supported in air. So you will be having a natural air cooling. And once again I am repeating, they will be carrying currents of hundreds of amperes, which means that large amount of power will be dissipated at that point, right? So air cooling will be provided. And the ability to tap in at various points without creating a new joint, that is the biggest advantage. Now where we do use this one, particularly in industrial and commercial settings, particularly where you do have a high budget. In home I cannot maintain a bus bar, right? So rather than maintaining a bus bar of high cost, I can just only tie up the wires, right? So but whereas when you do have a commercial area or an industrial area where you do have lots of budgets, so most probably data centers, factories, office buildings will employ this type of bus bars. And particularly the transportation, electric transportation system nowadays, it is employing bus bars now. So electric trains, buses, etc., where they provide power to the vehicles through overhead lines or rails, they'll be connected to this bus bars. So coming to sizing of the bus bars. So the material composition, whether it is copper or aluminum or brass or whatever it might be, and the size of that one, the thickness, it depends upon the application which we are using. So based upon that thickness, automatically the current, maximum current which is allowed through that one, it will be varying. So the bus bar's material composition and cross-sectional size determines the maximum current it can safely carry. So normally the cross-sectional area will be as little as 10 square millimeters. But in electrical substations where you will be having too much amount of fans, you can have metal tubes of 50 square mm or 2000 square mm also of diameter. So it depends upon the application. So based upon the thickness, automatically the maximum current which you can allow through it will be varied. So now this is a representation of the bus bar. See, this is a copper bus bar. This is an aluminum bus bar. So I'll be doing holes here. So you can pick your wires here. Right, like this. With the help of bolts and screws, you can have that. See, this is your holes have been made, and in these holes you can keep your wires, and you can bolt them, tie them with the bolts. Okay, so this is a stiff one. See, this is a little bit adjustable one, right? So different types of bus bars are available in the market. See, this is how it looks like. See, this is different wire, this is different wire, different wires, different wires. All have been joined here with the help of this hooks and bolts, right? So this is the way how bus bars. So if I want to remove this connection, so I will directly remove this screw and I will just take out of. So it is easier for maintenance, right? So it is just nothing but an electrical joint, what I can say it. So now this one is made up of copper. So it is a copper bus bar. See, there is no insulation which is provided here. Now, so normally the incoming wires or the outgoing wires, they will be connected to these pins, gut pins, what we call them. So, and that it will be fitted to this bus bar with the help of screws, right? Now, what is the need for bus bars? So, why should we go with the bus bars when, means the biggest thing is power distribution will be very efficient when compared to the traditional wiring systems. Traditional wiring systems, they may not be able to handle high current loads, and the joints may create some sort of disturbances, and also they can provide some sort of resistance. But this one bus bar is purely a conductor material, so it normally can handle high currents, and at the same time it can offer the least impedance or low impedance. This provision of having low impedance, it will automatically reduce the losses of the system. So during transmission, so bus bars, they provide a more efficient means of distributing the electrical power. At the same time, they are designed to handle high current loads, even up to 1000 amperes or 5000 amperes. Also, you can allow the current to pass through this one based upon the thickness of the bus bar which you are employing. And they do have low impedance, which reduces energy losses during transmission. And the second thing which I have already told you is the flexibility. So they can be easily adopted to changing power distribution needs, right? When compared to the traditional wiring systems, I can't always remove the joint and join new wire. So that thing is eliminated with these bus bars. If you do have a new wire, you just make some hole and fit it directly into the bus bar. So they can be easily modified or expanded. So you can join one bus bar to another bus bar also, right? And the flexibility which they do offer, they can be easily adapted, right? And they can be easily modified or expanded. And the next thing is, yeah, I think I repeated that one, right? And the next thing is spacing. See, they take very less space than the traditional wiring system. This is very useful, particularly in case of buildings where the space is a constant. So bus bars are normally flat and they can be installed in vertical or horizontal configuration, which saves space. So the volume also will be very small. Nowadays, adjustable bus bars are also there, shape varying bus bars also. You can choose based upon your requirements. And improved safety. Since bus bars are enclosed in a protective housing, so it provides a greater safety for you when compared to the traditional wiring systems. So any accidental contact with the live conductors also, it will be eliminated because everything is provided in the housing. And the installation time also is very, very low because you can directly join it with the help of some sort of screws. So easy installation, easy improved safety, higher flexibility. So these are the advantages which you do have with this busbar mechanism when compared to the traditional wiring system. So are there any, now so far we have been discussing only the advantage, right? So a quick review of the advantage and also the disadvantage which you do have with traditional when compared to the traditional electric wiring system. So as already told you, the advantage, electrically very safe installation, right? And drastically reduced space required inside the cabinet. And troubleshooting is also very easy. And all the short circuit ratings are already pre-tested, so you can adjust them. And you can mount 2, 3, 4, 5 poles which are also in a single construction mechanism. This we will see in the unit number 4. And also time saving during construction. So these are the advantages which we have already discussed. Now, are there any limitations for this one? Yes, there are some disadvantages. See, it is commercially not viable. If the number of switchgears is low, then you don't need to bother about the busbars. You can go with the traditional wiring systems because it is not commercially viable. A thick copper bar is very costly. That's why most of the people have been using aluminum, but still it is costly when compared to a traditional wiring system. If the number of switchgears is low. And for erection of all these things, you do require specialists, right? A normal person cannot do these sort of things, right? And lack of adapters for mounting different electric devices on the bus bar. This is also one biggest problem. And for currents more than 800 amperes, you do require special type of bus bars, and it may prove costly for you. So these are the disadvantages. So if the number of switchgears is low, then traditional wiring system is good. If the number of switchgears is high, and if you do have specialists, and if you are more concerned about your safety, then you can go with the electrical bus bar system. So with this, I will close this session, and we will discuss an extension of this session. Right.